Okay, Assalamualaikum and a very good day. I bid to Dr. Ibrahim and my fellow friends. So today we are from the group A. We'll present our coordination compound, which is tetracarbonyl and ICO4. So before we start with our presentation, I would like to introduce my group member. So the first one is Nur Aisyah Nabilah binti Nur Azlan. The second one, Nur Aina Humaira binti Kamarul Zaman. And the last one, which is me, Nur Atirah binti Abdul Romli. So you guys cannot see my picture there, but it's okay, you can see my face. And next, we proceed with the table of contents. We will start our presentation with the method of synthesis, continue by the point group information, ligand field theory, spectral properties, magnetic properties, geometry of compound, application, and the last one is the references. So Aisha will start the presentation with the method of synthesis.
So I will explain first about the method of synthesis for tetracarbonyl nickel. The nickel is the only metal that readily react with carbon monoxide at room temperature and also atmospheric pressure. The reduction of nickel side in solution in the presence of carbon monoxide is often complex. Tetracarbonyl is not readily available commercially. So the reduction with dithironide as the laboratory procedure where the dithironide is oxidized to the sulfide. As you guys can see in the first equation where the Ni2 plus ion plus S2O4 2 minus, which is the dithironide plus 4OH, will form the tetracarbonyl nickel plus 2 sulfate and plus 2 water. Other than that, carbon monoxide itself acts as the reducing agent in the reduction with the nickel sulfide or selenide being itself oxidized to carbonate. As you guys can see in the next equation, where the nickel sulfide react with 5 carbon monoxide plus 4 OH minus will also form the tetracarbonyl nickel. Other than that, the kinetic of the reduction of nickel chloride by the carbon monoxide in aqueous ammonia will also form the tetracarbonyl nickel. So next is Tirol.
So next is the point group determination. Okay, as this picture shown here, we can see that the structure of the NiCO4 is tetrahedral. So let me show you this animation of this compound. Here we can see that this compound has the symmetry element E, C3, C2, S4, and sigma D. Since the structure adopt the tetrahedral geometry, so we can conclude that the point group of this compound is TD. So next, continue with the ligand field theory.
So basically, there is three type of ligand that in bonding, which is the sigma bonding, sigma bonding, sigma acceptor, and also pi acceptor. And based on the ligand field theory, the metal to ligand acceptor bonding, which is the pi back bonding, and the ligand to the metal sigma bonding is energy. It means that when the ligand to the metal pi sigma bonding increase electron density on the metal, it will also increase the degree of the metal to the ligand pi back bonding. The pi acceptor on most ligand are higher in energy than the metal d orbital. So they will form molecular orbital which the bonding T to G combination are largely of metal d orbital character. So in our group, the coordination compound, which is the tetracarbonyl nickel, where the carbonyl will bonded to the nickel, as the carbonyl is a strong field ligand, cause the pairing of valence electron in the nickel atom. Carbonyl is a pi acceptor ligand, which is a ligand that has an empty pi orbital that are available for occupation. So as you guys can see, the pi acceptor orbital are vacuum anti-bonding orbital on the ligand. Usually the LUMO, as in the carbonyl, which is the ligand that bonded to the nickel, has a higher in energy than the metal d orbital. So as you guys can see in the picture, where the metal and the ligand, the energy for the ligand is higher than the metal. So it will increasing the splitting energy. So as you guys can see at the picture above, there is 4 types of pi, which is the pi donor, with pi donor and no pi effect, and also the pi acceptor. Pi acceptor is the strongest one. So the carbonyl is in this group, which is in the pi acceptor group. So it will increase the highest splitting energy. The two pi knot orbitals of carbonyl have their largest amplitude on the C atom and have the correct symmetry for overlap with the metal T2G orbital. So carbonyl can act as a pi acceptor ligand in these compounds. So next,
So next is about the spectral properties of this metal complex. Okay, as Atira said before, tetracarbonyl nickel is a complex with a geometry of tetrahedral TD, and it has 9 fundamental vibrations, which is 2A1, 2E, 4T2, and 1T1. Okay, eight of them are Raman active, which is A1, E, and T2. 4IR active, which is T2 mode, and 1 inactive mode, which is T1. Okay, the most reliable data is provided below. But today I would like to stress out about I would like to focus on more to the IR spectrum, the IR active mode, which is T2. So based on the data, if in the data below, for the if we have a tetracarbonyl nickel in a gas phase, for example, in the table below, at the second row, it is stated that the T2 would have a peak at around 2057.8. Same as the spectrum that I will provide it at the next slide. Okay, in this slide, you guys look at the peak at 2058 peak. This peak occurs due to the CO stretching bond from the T2 modes that I said before. So, that's it.
Okay, so now we continue
Next for
with the,
magnetic property.
okay. We continue with the magnetic properties. So the magnetic properties for this NiCO4 is diamagnetic. So before we determine whether it's a diamagnetic or paramagnetic, we need to know these few key points, which is the oxidation state for the metal atom. As for the nickel atom, the oxidation state is 0, and the electron configuration is argon 3d8 4s2. The coordination number is 4, and the ligand, which is the carbonyl, is a strong field ligand. So let's see the explanation why it is a diamagnetic. So first here, the first picture, we can see that this is the electronic configuration of nickel atom in ground state, which is 3d8 and 4s2. In the second picture, okay, we can see that this orbital is now fully occupied. How this is happened? Okay, CO ligands is a strong field ligand. So when CO ligands approach nickel atom, it will cause the pairing of the unpaired 3d electrons and also causes the 4s electron to be shifted to the 3d orbital. So that now the 3d orbital is fully occupied, as the unpaired electron be paired and the electron in the 4s orbital shifted to the 3d orbital. So the empty 4s and 3 4p orbitals will undergo the sp3 hybridization, and it will form bonds with the CO ligands to give this coordination compound, the tetracarbonyl nickel. This compound is tetrahedral because it undergo the sp3 hybridization. So the previous slide, I said that this compound is a diamagnetic. Why it is a diamagnetic? Since there are no unpaired electron present in this case, which is, we can see here, all of these are paired and fully occupied, thus the NiCO4 is diamagnetic. So next, we continue with the geometry of NiCO4. As I had mentioned before, the geometry of NiCO4 is tetrahedral, and the bond lengths are as shown below. Nickel to carbon bond length is 1.82 plus minus 0.03 angstrom, and the bond length C and O is 1.15 plus minus 0.02 angstrom. the bond lengths are same. Why they are same? This is because the electrons are symmetrically symmetrically filled at the d orbitals. Like I had mentioned before, the d orbitals are fully occupied when the electron ligands approach the nickel atom. So since it is fully occupied and symmetrically filled, this NiCO4 will not undergo any distortion effect. Thus, we can assume that this NiCO4 is a perfect tetrahedral geometry. And for the last one, the application, Myra will continue this.
Alright, the last one is the application of this tetracarbonyl nickel. Okay, firstly, this metal complex is widely used in the glass plating. And then it is used primarily as a carrier of carbon monoxide in the synthesis of acrylates, which is the compounds utilized in the manufacture of plastics that we usually use in our daily life, used in the manufacture of nickel powder and nickel coated metals. This is the most important one. It is used as a catalyst in various chemical reactions, such as carboxylation, coupling, and cyclization reactions. And lastly, it is used in refining nickel ore. Alright.
So that's it from us. So this is our references that we use to finish this task. If you guys have any question, you can ask us after you finish watch the video. Hope you enjoy our presentation. That's it from us. Thank you. Bye-bye.
Watch the video again.